Assalamu alaikum. Today I am going to make a tutorial on three different edge detection algorithms and then I will compare their values using PERF. So basically, edge detection includes a variety of mathematical models that aim at identifying points in a digital image at which the image brightness changes sharply or more formally has discontinuities. The points at which image brightness changes sharply are typically organized into a set of curved line segments, and those segments are termed as edges. So, edge detection is a fundamental tool in image processing. It is also used in machine vision and computer vision, and particularly in the areas of feature detection and feature extraction. The algorithms which I will be use are number 1 Sobel edge detection, number 2 Laplacian edge detection, and number 3 Canny edge detection. I will briefly discuss these three algorithms and then we will move on to the code. So if I discuss Sobel operator first, the Sobel is one of the most commonly used edge detector. It is based on convolving the image with a small separable and integer valued filter in horizontal and vertical direction, and is therefore relatively inexpensive in terms of computation. The implementation which I have used, the algorithm which I have used implementation is in Python, and the library which is used is OpenCV. So basically OpenCV is used for all these algorithms as it made the code really easy. Our algorithm is already implemented in this library. The second operator is Laplacian operator. It is somewhat different from Sobel because the Laplacian edge detector only uses one kernel, which means it calculates second order derivative in a single pass. So basically it uses two masks as a second derivative measurement on the image that are very sensitive to noise. And the third operator algorithm which I have selected here is Canny operator. Canny edge detector is probably the most commonly used and most effective method. It can have a much more complex edge detecting method than the one which I have described above. However, in short, we can say that for soothe the image with the Gaussian filter to reduce noise, we can use Canny filter. So now we will move on to the code. First, I will open the Python file for Canny. This is basically the code which I have taken from internet and it is implemented using OpenCV. So this CV2 is actually the library known as OpenCV. NumPy library is used for mathematical calculations and matplotlib is actually used to draw the image. The image which I have taken, let me show the image first, which I have taken for the edge detection. So this image I have used for all the algorithms. And the Sobel and Laplacian code both are implemented in the same file. Again, these three libraries are used. This is the code for reading the image and then it convert the image to the grayscale first as it is the colored image. So this line will convert it into the gray code as this is the requirement for the code. Then it will remove noise. Again, it is using the OpenCV function which is known as Gaussian blur, which actually take the grayscale image. And then Laplacian and Sobel both filters are applied and plot is used for plotting the both images. Now if I open the terminal and let me run the code first. For that I will type Python 3 and then the file name. So I will run the Canny file first. You can see the difference between the original image and the edge image. Original image is changed into the grayscale image and then it is converted into the edges. So this is the output of the Canny algorithm, and if I run the Sobel and Laplacian one, so these are the result for Laplacian and Sobel algorithms. Now we will move to the analysis of the system. For that we will use PERF command, and if I run the perf command on Canny file first, then this is some of the output for the first run. As you can see, in the first run, context switches are one context switch, 137 page faults, and 3.071 gigahertz. So this is cycle frequency, and number of instructions are 0.71 instructions in per cycle, and branches are 427311, whereas branch misses are 19056. That means 4.46% of all the branches are missed. The time it took in seconds are 0.0012. So if I rerun it for the second time, let us see if there is any difference in the second run. So for the second run we can see little changes. The time it took is 0.0013, whereas previously it takes 0012. So very minute different. The branches missed on the first run was 19056, which is 4.46% of all branches, and this time it is 4.52 of all branches. So little increase in the numbers. Page fault is 137, it remains same, and instructions were 0.71 at the first run and 0.70 at the second run. For the third run, almost the instructions are same. Time is little less this time. This is the fourth run, and this is the last run, the fifth run. If I perform the same on the other file, on the other algorithm, that is Sobel, the stats here are the time it took in seconds are 0.0012 seconds, and the number of instructions per cycle are 0.72. The context switch again it's 1, and page fault is 137. For the second run it took 0.0012 seconds. So there is very minute difference in the time. So in the next milestone I will take different images to see the different behavior, to see the difference in the behavior in both filters.